All right, welcome to the table question of the FRQs. All right, the table question gives you a table. I bet you did not assume that, but it does. It gives you a table of values. And the things that we really used a table for this year in AP Calculus is estimating derivatives, which was average rate of change, f of b minus f of a over b minus a. Verifying that function values exist, which is intermediate value theorem. Verifying derivative values exist, which is mean value theorem. And doing Riemann sums. Lots of Riemann sums. Pretty much guarantee a Riemann sum when you see a table of values. They also like to mix some random thing with it. So you may see elements of a rate question, you may see elements of a particle motion question or something like that. It could really be anything that they like to mix in with these because they usually don't just ask these four things. Things to watch out for. Just like with the rates question, you're going to watch out for your units. To get units for a derivative or rate of change, you're doing the units for f over the units for x. If you were doing an integral, you do the units for f times the units for x. With overestimate and underestimate, make sure for part of your explanation that you include what kind of Riemann sum you did and if the function was increasing or decreasing. Those two things are critical when explaining whether a left or right Riemann sum overestimated or underestimated. Remember, we can also do trapezoidal based on concavity. All right, so water is pumped into a tank at a rate modeled by W of t 2000 equals 2000 e to the negative t squared over 20 liters per hour. Yeah, where t is measured in hours. So those are important things to note. We've got some units, liters per hour. T is measured in hours. Water is removed from the tank at a rate modeled by R of t liters per hour. So R of t is in liters per hour, and that's the removed. Should also note that W of t is pumped into the tank. R is differentiable and decreasing. Those are important things to know. Selected values of R of t are shown in the table above. At time t equals 0, there are 50,000 liters of water in the tank. So, like I was saying, I see a lot of elements of a rate question in here. We got water being pumped in. W of t is my rate in. R of t is the rate out. 50,000 is the initial value, right? So we see a lot of those same rate ideas. Okay, so first thing I'm going to do is estimate R prime of 2, show the work that leads to your answer and indicate units of measure. So if I want to estimate a derivative value, what I'm going to do is I'm going to find the smallest interval on this table of t that contains t equals 2. And that's going to be right here. That is the smallest interval of t values that contains t equals 2. Now, I'm going to do average rate of change for this. Average rate of change is the best we can do for getting derivatives when we have a table of values. We can only estimate them. So we're going to do 950 minus 1190 divided by 3 minus 1. And that is equal to, once you do all the division and all that fun stuff, negative 120. Now it says indicate units of measure, so we have to be careful and actually do that. The units of measure, so we did a rate of change, so it should be the units for F, in our case it's R, liters per hour, per hour. And I think this is actually a really good place to see that, right? These top values are R values, R of T values. And these values are T values, right? So it should be the R units over the T units. So that seems to make sense. All right, now all the annotations are gone, but remember what we talked about, rate in, rate out, initial value. R is decreasing and differentiable. Use a left Riemann sum with the 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. Is this an overestimate or an underestimate of the total amount of water removed? Give a reason for your answer. Okay, first thing we got to do, the left Riemann sum, right? They told us to do a left Riemann sum, we had better do a left Riemann sum. So the first thing I see is here's my first subinterval. I'm going to use the 1340 times the width of the interval, which is 1, plus 1190 times the width of the interval, which is 2, right, because this next interval. Now I'm going to do 950 times the width of the interval, 3, plus 740 times 2. So there's my Riemann sum. And you have to write these numbers out. You can't just jump to an answer. You have to write these numbers out because these numbers, specifically written this way, are indicating to the grader that you know what a left Riemann sum is, that you're starting at the left-hand side. So you have to make sure to include that. So once you do all that evaluation, those calculations give you 8,050. Now it doesn't ask for the units, but we could very easily get them. So units for we Riemann sums estimate integrals, so it should be liters per hour times hours, which is just 8,050 liters. So again, it doesn't ask for them, but just to illustrate that we can get them. Okay, now I'm going to erase this stuff because I have another part to answer and I didn't really leave myself room. So let me erase this stuff real quick. All right, the next thing it asked was, is this an overestimate or an underestimate of the total amount of water removed? So what we need to do is think about left Riemann sums, and we know that R of t is decreasing, right? It says decreasing right here. So I've shown you guys before, I always sketch this out for myself. So I'll draw some decreasing function. It doesn't really matter what it is as long as it's decreasing. Left Riemann sum should have their upper left corner touching the function. So if I draw rectangles where the left corner touches the function, I can see that I'm overestimating. I get a little bit too much area. So what I'm going to say is this is an overestimate because R of t is decreasing and we used a left Riemann sum. You write RS just because I'm out of room, but you should write Riemann sum. You should actually write out the words. Now that drawing is for you, right? This little sketch over here, that's for you to justify. That's not a reason for your answer. I've had a lot of people do that before. Well, they'll just put that drawing and say that's the reason. That doesn't count. You have to explain in words what's going on. So that drawing is just to help you formulate your response. All right. Next one, use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. So this is where that rate in, rate out stuff comes into play, right? This is where we know that water is coming into the tank. We know water is being pumped out of the tank. So we have to do some integrals and we have to consider the initial value to get an amount, right? So we're going to do 50,000. Water is coming into the tank at the rate W of t. The interval should be 0 to 8. Water's coming out of the tank at a rate R of t. Okay, that represents it. That actually would be the value. Now, we don't know how to get the integral from 0 to 8 for R of t, but we just estimated it in part B, and that's what C is telling us to do. Use the answer from part B to find an estimate of the total amount of water in the tank. So what we're going to do is we're going to use the calculator for that integral. We're going to use the estimate that we got in part B for that one. And once you actually do that, you go into the calculator and do those calculations, you get about 49,786 liters. Right, and this is one of those cases where it says to the nearest liter. When you go into your calculator, you're going to get lots of decimals because that W of t integral is going to be messy. But it says do it to the nearest liter, so round to the nearest liter. All right, last little bit, and this part's tricky. This part's definitely challenging. It says for 0 to 8, is there a time t when the rate at which water is pumped into the tank is the same as the rate at which water is removed from the tank? Explain why or why not. So what we're going to do is we're going to say, what does it even mean for them to be the same? Well, literally what that means is, does W of t equal R of t ever? Now, if I knew what R of t was, that would be easy. I would just set them equal to each other, move everything to one side and grab it, but I don't know what R of t is. So what I'm going to do, I'm still going to move everything to one side. on the interval 0 to 8. Let's check both endpoints. Let's see, what is W of 0 minus R of 0? Well, W of 0, let me go into my calculator real quick. 2,000 times e to the 0. Oh, well, that's 2,000, right? So that's 2,000 minus 1340, which is equal to 660. Now let's check the other endpoint, because our goal is, we're trying to justify that this function has this function value, right? So that's an intermediate value theorem, and I should have said that a second ago. That's what we're trying to do. We want to know, does the function w of t minus r of t, does that ever equal 0? So remember what we're going to do, since we know these functions are continuous, we just need to check the endpoints and see if 0 is in between them. So now I need to plug in 2,000 times e to the negative 8 squared over 20, and I get 81.5244 minus 700. And we get negative 618.476. Okay, now I see the answer, right? I know that on the interval 0 to 8, w of t minus r of t goes from positive to negative. So that means it must have hit a 0 somewhere in between. Now we have to show this work because we have to justify things. Let me see if I can just duplicate this. I cannot. Okay, so whatever work that you see here, you may want to copy down. I need to erase it because I ran out of room. Okay, so we know the answer is yes. The reason being, yes, because we said w of t first, right? Because w of t minus r of t goes from negative to positive on the interval 0 to 8. I think it actually started at positive. On this interval and is continuous. Okay, so the reason that I know it's continuous is because w of t is an exponential function. Those are continuous. And it says r of t is differentiable. If a function is differentiable, it must also be continuous. So this is definitely hard. This is probably the hardest thing I've seen on a table question, really. But it was manageable. And parts A through C weren't really that bad. It was part D that was a little tricky. We just had to justify the existence of a function value, though. It's just our function was the subtraction of two functions. All right, let's look at our units again, or our points again. R prime of 2, we estimate with a derivative, and we get negative 120 liters per hour squared. Now I want to point out, you get 2 points for this. One point is for the estimate, 1 point is for the units. Sometimes, I can't think of exactly when it is, but sometimes you just get 1 point. It's the answer with the units, and if you miss the units, you miss the point. So make sure you're careful about that. Part B, that was the one where we wanted the left Riemann sum to estimate the amount of water removed. So that would mean that we have to do the left Riemann sum. That's this part right here. That is justifying that I did the left Riemann sum by showing that work. This is the actual estimate. And this is an overestimate since r is a decreasing function. Now you might notice they didn't include the fact that we used a left Riemann sum. You should, because sometimes they're pickier. You need to be very careful and include the fact that it's a left Riemann sum. Part C, an estimate of the total amount of water at time t equals 8. You got a point for setting up the integral, and you got a point for the actual answer. Part D was that tricky one where we wanted to know, did W and R ever equal each other? So we got a point for considering that W of t minus R of t. We got a point just for thinking about that, essentially. And then we got a point with the answer. In their explanation, they specifically mentioned the intermediate value theorem. You don't have to. Okay, that's it. That's our table question.